What the fuck is this problem, right? This problem seems to be insanely complicated, but it's actually not. Yeah, we can actually prove it. Like just using the multivariable central, we'll just build up on that slowly, and we will prove it. And yeah, we'll just need the multivariable chain rule. The problem basically says that x is equals to r cos s theta, y is r sin s theta, and b is function of x and y. That means b is also a function of r and theta because x and y are expressible in terms of r and theta. You can also see that, right? And we want to prove this. So first of all, before we begin, let's just get used to the multivariable chain rule, right? Oh, but like, okay, now how this works? Over here, you see that b is a function of x and y, right? And again, x is a function of r and theta, right? So let's say if you want to see how b changes with not with respect to x or y, but with respect to, let's say, r, right? And I'm writing is here partial because b, because this x and y also depending on r and theta. If let's say if both of these functions x and y were just a function of single variable, let's say t, in that case I could have written it as dv by dt because the total change in v is due to t. But in this case the change in due to r and theta, so yeah, they will just be partial. This is not the total change. Okay, now if I want to find, let's say, partial v by partial r, so basically from r both x and y change, right? So if I want to find the rate in which b change due to r, I need to find both the rate in which b change due to x, right? When there's a small change in r. So this is how, so this basically gives us how the change in r changes the x and how that change in x changes the b. And similarly over here, how the change in r changes the y and how that changes the b. So this is how multivariable chain rule works. Similarly, let's say if I want to find partial b by partial theta, that would just be this expression partial b partial y partial theta. Let me first write x, partial b partial x times partial x partial theta plus partial b partial y by partial theta, right? Now similarly, let me also give you another way of saying this. Let's say I can also write these two equations as like r as x square r square as x square minus y square, right? And theta as tan h inverse y by x, right? Okay, now in this case b is clearly a function of r and theta, and this r and theta now depend on x and y. Earlier x and y were dependent on r and theta, now r and theta are dependent on x and y, right? Okay, now let's say if you want to find partial b, okay, by partial x in this case. Now in this case, b is dependent on r and theta, and this r theta are then dependent on x and y again, right? So if there's small change in x, that will cause change in r, due to which b will change. But this change in x will also cause change in theta, which will cause change in b. So over here, if I want to find the rate at which b changes due to x, that will be this expression, which is basically the rate at which r changes due to x and how r changes b plus how x changes theta and then how theta changes b. This will be this expression. Similarly, partial b by partial y will be, so partial b divided by partial theta times partial theta by partial y plus partial b by, okay, let me first write r. Okay, partial r by partial y plus partial b by partial theta times partial theta by partial y. Guys, maybe you want to look these expressions a bit more closely, how these are working. Also, you might see that, like, if you see it as cancellations, these are just the. I mean, it might make more sense. However you want to see it, okay, you can see it however you want to. Like, and yeah. So this is the thing that we're going to use to prove this. Now, in this video, I mean, in this very problem, we are basically asked to get from here to here, right? So basically we want to use partial b partial x these expressions and get it in terms of these expressions, right? In terms of partial b partial r partial theta, right? And we will basically know these middle expressions because we can find it from this expression itself. I mean, from here we can find partial r, partial x, partial theta, partial x, right? So these will basically be known, and I mean these will basically be known values, right? And these will be unknown values, right? And in terms of this, we need to find the value. Like basically, we have to first find the second partial derivatives with respect to x and y, and we have to get some expressions over here. We can substitute these values, and the remaining values will prove this section, prove this formula basically. So I hope you get the idea, right? So yeah, let's start finding the second partial derivatives of this thing, and see what we get. Yeah, that's a good exploration, and that's the only hard thing, like how to find second partial derivatives. After that, it's all out easy. After that, there's really nothing at all. So yeah, do bear with me. So now let's start the formal solution. First of all, I will just try to find this expression only. So from all the experiences that we gathered till now we know that partial b by partial x, since this x can cause change in r and theta, which can again, see it this way, x can cause change in r and theta, which can again cause change in b, which can again cause change in b. So over here we can write it as change in yeah, change in x changing r due to is b is being changed, and x changing theta due to is again b is being changed. This is the multiplication rule, right? Now we again want to differentiate both sides with respect to x, right? Basically partial differentiate. Partial, not, it's not diff. Partial differentiate both sides with respect to x, right? Now if I do it to this side, partial x of partial b by partial x, this will not be too hard. This is just partial square b by partial x square, just notational thing. Over here, we know that this partial operator is linear, so I can just distribute it one by one, right? I don't think this is a problem for many of you guys. Oh yeah, over here it's not b, it's x actually. I'm sorry, that's x. Okay, now this is just partial square b by partial x square, right? Now over here, since there's a product, we need to use product rule, right? And if I use product rule, I will just get partial x times partial b by partial r, and okay, derivative of first thing I took it. Now second thing will be as it is, without it will be untouched. Now first thing will be untouched, and derivative of second thing. So partial x of, guys, see, so this is being long, but it's not hard at all, guys. Don't mistake it for being hard. It's definitely long, but it's not hard. And partial x, partial b by partial theta. So first thing derivated, second thing untouched. Now first thing untouched, second thing derivated, right? This is how it works. That's just the product rule. Okay. Now again, there's another big question. First, I'll just do something. I'll just make some changes before I like get to the next step. So notice that this will just remain as it is for now, because this is not, also later what to do with this. Yeah, because, and the next thing is simpler, because next thing has partial x. So this will just be partial b by partial r times partial square r by partial x square, right? And yeah, but let me write it later on. I will write this later on. First of sorry, I will write this later on. First of all, let me write the third element, this one, partial by partial x, partial b by partial theta by partial x, right? And let me write the other remaining ones, partial b by partial r, partial square r by partial x square, plus partial b by partial theta, partial square theta by partial x square. Okay. Now how do we take partial derivatives of these things, right? Now notice that this partial b by partial r. So even if I take the partial derivative of b with respect to r, it's still possible that partial b by partial r will still be a function of r and theta, right? So let me say, like, let's say if v was r square theta square, right? In this case, even if I take its partial derivative with respect to x, this is 2r theta square, right? So this can still be a function of r and theta. So this thing over here, this can still be a function of r and theta. Similarly over here as well, this partial b by partial theta will just be r square 2 theta, right? So this can also still be a function of r and theta over here. So why I'm saying that, why I'm like focusing on that is, now if this still is a function of r and theta, this x can cause change in both r and theta. So you again need to use multi-variable chain rule, right? If this was a function of single variable, then that would not have been problem. But since that's still a function of two variables, you need to use multi-variable chain rule, right? So yeah, now let's do that. So with this idea, now it's all a pretty easy thing. Now there's literally nothing. Now there's nothing any complicated. So this was the like a bit complicated thing. Now, okay, so we are on the partial derivative with respect to x of this function, right? Now you can just see it this way. So there's this function, and this function of basically r and theta. So what will you do? Again, so we will just differentiate, like r can cause change in, I mean x can cause change in r, which can cause change in the function. Again, x can cause change in theta, which can cause change in function, right? So you write it this way, right? So do the same thing over here as well. Do the same thing. So basically x can cause change in r, which can cause changes in this which can cause change in this expression. Yeah. So yeah, if x can cause change in r, which can cause change in expression, again x can cause change in theta, which can cause change in this expression, right? Okay. So yeah, the first one done, and also notice that there's this partial r by partial x, which you should not forget. Now again for the second one, it's long, but definitely it's not too hard, guys. Yeah. Now again for this one, this is again a function of r and theta, right? So x can cause change in r, which can cause change in this expression, right? X can cause change in r. Again, x can cause change in theta, which can cause change in this expression, right? And there's this d theta by dx, which you should not forget. And now other things are already simplified, so you need not worry about that. Partial b partial r, partial square r by partial x square, partial b partial theta, partial square theta by partial x square. Right? Okay. Now after this, there's not a lot of thing now. There's not a lot of thing now. Don't worry. Now we are almost at the end of this movie, right? So partial b partial x square is equals to, now notice that there's partial r partial r, it's same, right? So this is just partial square b by partial x square. Now there's some glimpse of hope, because we exactly needed partial b by partial r square, right? So yeah, we got the one of those expressions. And now this is just partial r by partial x plus, now this is again, now notice that this is first of all differentiated with respect to x, sorry, r, and now theta. And this r and theta are of the same world, right? Because x and y are of same world, r and theta are of same world, right? So this theta cannot cause change in r, right? If this theta could have caused change in r, we would have again used multi-variable, like, if let's say, because here theta and r of different world, and this can change each other, so we use multi-variable chain rule, right? But in the world of r and theta, these two are independent. So yeah, so these two are independent variables and are the same world. So what happens is, we'll just differentiate this p with respect to r and then theta. So we write it like this. It's just the same thing as double derivative, but with different variables, right? Yeah. And this is partial theta by partial x. Guys, I hope we have understood why we didn't just write partial b by partial x partial r over here, but we here did, because these were of different world, and these are dependent variables, but these are of same world. This r and theta and the independent. So I guess you get that, right? Yeah. And this is partial r by partial x plus. This is again, they are of same world. So this will be partial b by partial r partial theta times partial r by partial x, plus this is partial square b by partial theta square, and this is partial theta by partial x times partial theta by partial x, plus partial b by partial r times partial square r by partial x square, plus partial b by partial theta times partial square theta by partial x square. Wow. So now everything is simplified. Now you might also know that, like, if I let's say this function is of r and theta, right? So if I differentiate this function, like first theta and then r, the result will be same as first differentiating with respect to r and then theta. This is actually a theorem. This is called Clairaut's theorem, right? Clairaut's theorem. And yeah, you can easily check this over here also. If you, let's say if you want to check, we had f is equals to r theta square, right? So if you first differentiate with respect to theta, then this will be 2r square theta, right? Now if you do it this to r, this will be 4r theta. Similarly, if we had done first with respect to r, then it would have been 2r theta square, and then theta, it's same actually, you can see it, right? And this is also called Clairaut's theorem, and yeah, this works. So over here also, we want to use this. We will use this later on. First of all, let us do some more algebra before going there, because we have to multiply with this expression inside the brackets, right? That's a style thing, but we still have to do. So over here it's partial square b by partial r square times partial r by partial x whole square, plus, now this is partial, okay, but before writing this, I'll just write the product of these two expressions, right? And later on, I will do for this one and this one. Yeah, because yeah, that makes sense. You will see why I'm doing this. So if I multiply this is this two, partial square b by partial theta square times partial theta by partial x whole square, right? Now only I will write this. So now this was partial square b by partial theta partial r times partial theta by partial x partial r by partial x, right? Now I will write this one multiplied by the outside thing. So this will be partial square b by partial r partial theta times partial r by partial x partial theta by partial x, right? And this one is already written. This two products is already written over here. Now remaining the things are this partial b by partial r partial square, sorry, partial square r by partial x square, plus partial b by partial theta partial square theta by partial x square, right? Good. Now there's this final expression. I have also derived this expression in one of my previous videos where I had basically talked about 5 levels of chain rule in calculus. So you can, if you had checked this video, like, you would have already known this one, right? Okay, so partial square b by partial x square. So now this is just partial b by partial r square times partial r by partial x whole square, plus partial square b by partial theta square times partial theta by partial x whole square. There's some patterns, right? Now in these two are equal because there's this partial r partial x in both of them. This is also in both of them. This is also same, right? This is just Clairaut's theorem. So we will have partial square b by partial theta partial r and partial theta by partial x partial r by partial x. There are twos of them, so I write 2 over here. And then the final thing, which is partial b by partial r times partial square r by partial x square, plus partial b by partial theta times partial square theta by partial y square, right? Oh no, it's not y, it's x, partial x square. Now I do not need to do this again for y, right? Because I can just change x by y's because it's the same thing. Just like x was affected by r and theta, so this one was there. It's same. Y is also affected by r and theta, and the formula will be same. So over here, this will be partial square b by partial y square will be partial square b by partial r square times partial r by partial y whole square, plus partial square b by partial theta square times partial theta by partial y whole square, and then this one expression partial square b by partial theta partial r, partial theta by partial y, partial r by partial y, plus partial b by partial r times partial square r by partial y square, partial b by partial theta times partial square theta by partial y square. So now what we just need to do is we just need to subtract second from first, right? And so we get this required expression over here. And there are these things too. But there are a few other things too which are not over here, and I'm definitely sure that these other things are going to cancel out. So yeah. So now to before we find this, we need to get these like partial r partial x, partial r partial y, partial theta partial x. We can find this from the given formulas, right? And we need to substitute over here. So basically what we need to substitute over here is these things, because this partial b partial r we cannot find them, right? I mean, we cannot find these partials of b, but we can definitely find these partials of theta and y, theta and x, r and y, r and x, right? So yeah, we will try to find this and substitute, and after we have substituted, the game will be over. So now our only task, and this is the easy task, believe me, this is the easy task, just to find. So we need to forward. Okay, first of all, let us list out what we need to find out. We need to find partial. Okay, we need to find. Okay, I'll write over here. We need to find. Writing big handwriting because okay. We need to find partial r by partial x. We need to find partial r by partial y. What else? Partial r partial x, partial theta partial x, partial theta partial y, and then their squares, right? Yeah. Okay, let's do it. And then and then partial theta partial x, partial theta partial y, and then partial square r. It's not too hard, guys, because in this case I'll show you why it's not too hard. Partial x square, partial square r by partial y square, partial theta square theta by partial x square, partial theta partial y square. This is actually not too hard. Okay. Now, first of all know that first of all know how to express like r and theta in terms of x and y, right? We know that till now we have already learned that, like we have already learned that. Okay, from here we already know that r square is x2 minus y square and tan theta is tan s theta by x, right? So you already know that r square is x square minus y square and tan s theta is y by x, right? So based on this, we have to find partial r partial x, and this is just a few lines work, right? Okay, so shall we begin? Are you ready? Yeah. Okay. So first of all, try to find this of r's. So we have r square is equals to, so okay. So we have r square is equals to x square minus y square, right? Now if I make a like partial diff with respect to x, partial diff with respect to x, so this will just be 2r times partial r by partial x will be equals to 2x, right? So partial r by partial x, because y is just constant, so that goes to 0. So this is just 2x by 2r, which is just x by r. So I got the expression, right? So this is just x by r, right? Now let me find partial r partial y. Again, we know that r square is x square minus y square, right? Now if I make a partial differentiation with respect to y, this will just be 2r times partial r by partial y is equals to minus 2y, right? So partial r by partial y is just minus y by r. So that's easy, right, guys? It's not too hard, yeah? As I told you, I never lie. So this is minus y by r. Now let's find partial theta by partial x. Again, we have tan s theta is equals to y by x, right? Now if you partial differentiate with respect to x, or let's say with respect to y, let's say x. So you get sec h square theta times partial theta by partial x will be equals to minus y by x square. Now take this sec h square to other side. Partial theta by partial x is equals to minus y cos h square theta by x square. If you want this expression in terms of x and y, we know that cos h theta is just x by r, right? So if we use that, this is minus y by x square times x square by r square. So that's just minus y by r square. You see that? This is just minus y by r square, right? So yeah, this is the expression minus y by r square. So this is minus y by r square. Now this one, we want to find partial theta partial y, right? So we know that tan as theta is y by x, right? Now if I differentiate, now if I make a partial differentiate with respect to x, this will just be sec h square theta partial theta by partial y will just be equal to 1 by x, right? Sorry, I'm not doing with respect to x, with respect to y. With respect to y, already done with respect to x. So this will just be 1 by x, right? Now this sec h square theta goes to other side, becomes cos h square theta divided by x, and we know that cos h theta is x by r. So this is just x square by r square times x. So this is just x by r square, right? So partial theta partial y is just x by r square. So we got that this is just x by r square, right? Okay. Now we have got these four expressions. Now again, we need to get these other four expressions, right? Phew, okay. So now we know again. Now we will just build upon these previous expressions like that we have got earlier. We have got that partial r by partial x is just x by r, right? Yeah. I'll just take this r to the other side. Okay. So r times partial r by partial x is just x, right? Now I will. Now the reason I did this is if I had differentiated like both sides with respect to x, this r would not have been a constant because this r does depend on x, right? So this would have been a bit difficult to do. Though it's not really impossible, I can definitely do it. I'll show you later on. But yeah, this approach is easy. After I do this, I'll also show you how you can do it directly as well. I mean, not taking it to other side. Okay. So now for this one, so over here, first of all, if I differentiate r, this is partial r by partial x, right? And other will be as it is. I differentiated this first r. This will be as it is, and then plus now r, if I differentiate second, so this is partial r partial x square, and this will just be 1, right? Now we know partial r partial x is x by r, so this is just x by r square plus r times partial r by partial x square is equals to 1. So this is partial r by partial x square is equals to 1 minus x square by r square divided by r, right? So this is partial r by partial x square is r square minus x square by r cube, right? Now if you wanted to do directly, how you could have done is, I'll just show it and then I'll erase it because this one is actually good approach, but I'll just show you. Okay, so let's say if you want to differentiate this one directly, right? Okay, now how you can see this is, you can see them as x times 1 by r, definitely, right? Now just differentiate with respect to x. This will be partial square r by partial x square, right? Now if we use the product rule again, so the derivative of x will just be 1, right? And second will be as it is. Now x times we differentiate second one. So minus 1 by r square times partial r by partial x, right? So this will be 1 by r minus x by r square. If partial r by partial x is again x by r, right? So x by r. So you see that 1 by r minus x square by r cube, which gives us the same expression, r square minus x square by r cube, right? So yeah, it's not really different, but yeah, I just wanted to do it the other way because the other way saves space, right? Because sometimes, like, if I just do something on my own randomly, I feel that that does hamper the audiences, right? Because why is he not doing it directly? Why is he doing that? So just to address that, I make sure that yeah, I tell the things. Now to make the space, I'm erasing this. Okay, now we got this first thing as well. Guys, see, it's not that hard. I told you, right? It's not that hard. Now let's try to find partial square r by partial y square. We already know that partial r by partial y is just minus y by r, right? Now if I take r to other side, r times partial r by partial y is minus y. Now if I differentiate, this is just 1 times partial r by partial y plus r times, oh wow, sorry. If I this will not be 1, because if I differentiate r with if I differentiate r with respect to x, how can it be 1? This will just be partial in not respect to y, x with respect to y. I'll just write it there. I'll just write it. So partial diff with respect to y, this will be partial r by partial r by partial y plus. Now this will be r times partial square I by partial y square is equals to, this is just minus 1, right? Now we know that partial r by partial y is just minus y by r. So this is just minus y by r square plus r times partial square r by partial y square is equals to minus 1. So partial square r by partial y square is just minus 1 minus y square by r square divided by r. So this is just minus r square minus y square by r, right? We got the second one too. Now we are in the third one. So let's try to find partial square theta by partial x square, right? So we know that partial theta by partial x will just be minus 1 by r square, right? Okay. Now I can take r square to other side. So this is partial theta by partial x with respect to minus y. Now again, I will do partial diff with respect to x. Now in this case, notice that r square is not a constant. R square and theta both depend on x, right? So if I'm differentiating r square, this will just be 2r times partial r by partial x. Please know that. And then plus r square times, this will be partial square theta by partial x square. And now, since it's respect to x, this will just go to 0, right? Yeah. Okay. Now after that, now we know partial r by partial x, which is x by r, and this partial x is minus y by r square. So yeah, plus r square times partial square theta by partial x square is equals to 0. And over here, this r cancel out, so we have partial square theta by partial x square times r square as to be equal to 2xy by r square, right? So partial square theta by partial x square is just 2xy by r to the power 4. Is that it? Yeah, that it is. That's it, guys. Okay, now the last one. This last one, and it's done, guys. Just the last one and it's done. So okay, now for last one, we need to find partial square theta by partial y square, right? We know that partial theta partial y is x by r square. So this is x by r square. Let me take r square to other side. So r square times partial theta partial y is equals to x. Now we know that r depends on y. This is 2r times partial r by partial y times partial theta by partial y plus r square times partial square theta by partial y square is just 1, right? Sorry, it's on y, so it's 0 actually, because it's this is a difference with respect to y, so it's 0. And now we know that partial r by partial y is just minus y by r. This is just minus y by r, and theta by y, that's just x by r square, right? And plus r square partial theta by partial y square is equals to 0. Now this cancels and goes to other side. So r square times partial square theta partial y square is just 2xy by r square. Now goes to division. So partial square theta partial y square is just 2xy by r to the power 4. So we finally have all of them, and just now need to substitute and subtract, and we will get the answer. So yeah. Okay, guys. I'll just write this in a separate sheet of paper. Yeah, just write this result in separate sheet of paper. So because we are substitute this directly now. Yeah, let's substitute it now. So now, okay. So now if I subtract these two, okay. Now if I subtract these two, okay, guys. I'm gonna extend it a bit. Okay. Now if I subtract this two, let us see what we will have. If I do partial square, okay. If I do, sorry, if I do, why doesn't it zoom? Okay, fine. If I do partial square b by partial x square minus partial square b by partial y square. Now what I'm going to get is I will have partial square b by partial r square, right? And inside these two things will be subtracted, right? Partial r by partial x square minus partial r by partial y square. They will be subtracted, right? Similarly, in this partial b by partial theta square, we will have partial theta by partial x square being subtracted with partial theta by partial y square, right? I'm just going column by column, right? I'm just subtracting term by term. Again, for this 2 times partial square b by partial theta partial r, we will just have a partial theta partial x times partial r partial x minus partial theta partial y by partial r partial y, right? Similarly, si- similarly, okay. Now similarly, for partial b by partial r, we are going to have partial square r by partial x square minus partial square r by partial y square, right? And for partial b by partial theta, we are going to have partial square theta by partial x square minus partial square theta by partial y square, right? Now we know you just need to see this or see like how they end up. Now over here, let's analyze things. Let's analyze things. Over here, partial r partial x and partial r partial y. Let's see them. Okay, so they are x by r and minus y by r, right? They are x by r and minus y by r. So so this will just be uh, x by r and minus y by r. So that means x square by r square minus y square by r square. So that means x square minus y square by r square, and we know this is just 1. So I mean this is just r square. So r square by r square, which is 1. So over here this goes to 1. We see that, right? Okay, and that's why the coefficient of partial square via partial square is just 1 over here. You see that we are already getting the answer. In this difference of partial square v by partial square v by partial x square, and I'm sorry, it's not partial square x square. Okay, in this difference, this head to head coefficient 1, which we already saw over here, and that's already happening over here. So yeah, we are in a good track, right? Now okay, now let's see this one. Now let's see this one. Partial theta by partial x is minus y by x square, and the other is x by r square. So let's see, minus 1 by x square and x by wait minus 1 by r square x by r square. I'm sorry, this is minus 1 by r square x by r square, right? So this is y square by r to the power 4 minus x square by r to the power 4, and and this is and this is y square minus x square by r to the power 4. We know from here that x square minus y square is r square from here. So if we use that, this will just be minus r square by r to the power 4. So this will just be minus 1 by r square, right? So that means the coefficient of partial square v by partial theta square is minus 1 by r square. And that's exactly the thing over here. This gives intense satisfaction, right, guys? After all this work to see that the coefficient exactly matches, I don't know, like I cannot express like how much happiness it gives. Now, now next one, we know that this should have coefficient 0, right? Because it doesn't even appear over here, right? Okay, so if I were to have 0, this should be equal. Let's see if that's case or not. So partial theta partial x, which we see from here, over here, I mean over here, it's just minus y by r square, right? And partial r by partial x from here, it's just x by r, right? That's right. The partial x is minus 1 by r square and x by r here. Good. Now, partial theta partial y is just x by r square. And partial r partial y, that's just minus y by r, right? And this is just minus y by r. So we're evaluating this expression. So this is minus xy by r cube and plus xy by r cube. So that means 0 by r cube, which is 0. Which is why there's no this expression. This makes so much sense, right? And yeah. Now next one. Okay. So partial square r, now we want to find this one. Partial square r a partial x square. That's just r square minus x square by r cube. This is just r square minus x square by r cube. Now partial r square partial y square. Partial square r partial y square. Okay. Partial square r partial y square minus r square minus y square by r. Okay. Minus r square minus y square by r, right? And now okay, this is just r square minus x square plus r square plus y square by r. This is r cube, right? Now this is just 2r square minus x square minus y square. We know x square minus y square is r square, so 2r square minus r square by r cube, which is r square by r cube, which is 1 by r. And the coefficient of partial via partial r is just 1 by r. See? The coefficient of partial via partial r is just 1 by r. And yeah, that's exactly the thing. It's so much fun, guys. It's so much like happiness. Now, partial square theta by partial x square, which is 2xy by r to the power 4. So 2xy by r to the power 4 minus partial square theta by partial y square, which is 2xy by r to the power 4. So they cancel out, right? So this is just 0. So that means there's no this coefficient. There's not this coefficient, right? Yeah, there's no partial theta. So from here we can now write that from all this we see that partial square b by partial x square minus partial square b by partial y square is just partial square b by partial r square, which is coefficient 1, minus 1 by r square partial square b by partial theta square. This is 0. Now plus 1 by r partial v by partial r. The last thing is 0. So this is the expression that we wanted, and that's what the question is, right? That's what the question is, right? Partial square v partial x square minus partial square partial y square, partial square v partial r square minus 1 by r square partial. Yeah, that's exactly what the problem is, and we did it, guys. We did it. This was long, but definitely it was fruitful, right? We learned a lot of things: how to deal with partial derivatives, how to deal with multivariable chain rule, and a lot. So, guys, so I do hope that was helpful, and like and it's really like glad to hear that this all built it up from the only one simple thing: multivariable chain rule. See, guys, my maths is just like this. The things go on building and building, and they become complex. But yeah, the roots is simpler. So understand the roots, and you can do everything. So that was it, guys. Hope you enjoyed the video. Hope you enjoyed the solution. Thanks for watching, and look forward to seeing you in the upcoming videos too.